Hi, welcome to my neighborhood. It's a beautiful day here. I'm standing here on my friend Permu's patio. Sun's out. It's a lovely day. My friend Permu's lived here for about 30 years since she came to America. She has 2 children since then. One of them is named Permu, her daughter, and her son, Permu. Permu has a hobby. Permu likes to arrange flowers. And she has 5 colors that she loves: blue, pink, purple, red, and yellow. But for our purposes, we'll call them A, B, C, D, and E. Now, each day she'll come out, and she likes a little variety, so she'll actually change the order that they're in. And she cares about the order, so as far as she's concerned, this arrangement of flowers is different from the arrangement yesterday. And she's happy with that. But she asked me the other day if she could get through the whole summer without having a repetition of her flower arrangements. And so we had to figure out just how many of those arrangements there are. How many ways can I change the order of these and have them be different? Well, let's take a look at her 5 flower pots here. And when she picks the first flower, she has 5 choices: A, B, C, D, or E. Once she picks that flower, then she has another 4 choices left. So for every one of the 5 flowers that she picks, she has 4 choices in the next one. So far we have 20 arrangements of these 2 flowers. If she's used 2 there, then she has 3 left for this pot. So for these 3, she's got 5 times 4 times 3, which is 60 possible arrangements of her 5 flowers in these pots. She picks a flower over here. Now she's already picked 3, so there's only 2 left. And then finally she has no choice on the last one. There'll just be 1 left over. So how many arrangements are there then? Like I said, for every 5 of these, there are 4 choices here. And for every one of those, I have 3 choices. And for every one of those, 2. And then 1. So she has 5 times 4 is 20. Times 3 is 60. Times 2 is 120. Times 1 is 120 rotations of her flowers. And I like to call those permutations. So 120 permutations of these 5 flowers. That is the order changed so that they look different for her every day. So with 120 permutations, that's about 3 months. So she should easily be able to get through the whole summer without repeating. Now, her daughter and son live with her, and they live downstairs. She has a balcony up here with 5, but they only have room in their windowsill for 3 each. So they're only going to have 3 pots in each window. So let's look at how many permutations her daughter has. Well, there's still 5 flowers to pick for the first spot. And then when I pick one, there's still 4. And once I'm done there, there's 3. But then I'm out of pots. So the number of permutations she has is 5 times 4 is 20, times 3, 60 permutations. Last up, though, is Combine, her son. And Combine looks at things a little bit differently. To Combine, that arrangement is exactly the same as that arrangement. He doesn't care about order. So no matter how I change these up, it's all the same to him. His mother has 120 permutations, but for him there's only 1 combination. He really wouldn't be happy with this. He would feel like it's the same thing every day. He'd probably go buy more flowers. So what Combine would like to know is how long is it going to take him to run out of his kind of arrangements, which we're going to call combinations. And in combinations, the order doesn't matter. So whether it's A, B, C, or C, B, A, it's all the same thing. So here's Combine's problem. If he puts flower A in this pot, and B in this slot, and C in this one, and then the next day he does that, to him, these are the same. These are all one combination. So as far as he's concerned, he hasn't changed. How many of these could he make from 3 that would all be the same for him? Well, there would be BAC and BCA, and there would be CAB and CBA. So there are 6 arrangements that to him are identical. So how long will it take him? Well, he's basically the same as his sister in terms of the permutations that he has. But for every one of these arrangements that he picks of 3 flowers, there are 6 that are identical. So he needs to take his sister's number, which was 60, and he needs to divide it by 6. And 6 is the number of identical arrangements or combinations. So he's going to have 10 combinations. He won't even make it 2 weeks before he thinks he repeats. These are the basic ideas for permutations and combinations. There's a lot of notation that's very often confusing and somewhat difficult to understand, which we'll cover in a following lesson. But for now, the idea is pretty simple. However many slots I have, when I make my first choice, I have 1 less the next time, and 1 less, and so on, all the way down. So it'll always be the number I pick, times the number I pick minus 1, times the number I pick minus 2, minus 3, minus 4, etc. When I limit myself, it's really the same thing, except I have less buckets to put them in, which means I have less possible permutations. The least number of arrangements I have is combinations, because a number of these are identical. And so to get the number of combinations, I have to divide by that number to get 10. And that wraps this up. In a later lesson, we'll talk about the formal symbols that we use to talk about permutations and combinations.